This video is going to reintroduce you to the basic features of graphs. That includes where graphs are increasing, decreasing, and constant. We will always name those portions of the graph using an open interval. You should also be able to identify points that are relative minimums and relative maximums. A point is a relative minimum if it's lower than all the points immediately nearby, and a point is a relative maximum if it is higher than all the points immediately nearby. As a quick reminder, here's a sample graph. We would identify this point as the relative minimum. It is lower than all the points immediately around it. We say that the function has a relative minimum located at 2, naming the x-coordinate, and that the relative minimum value is 0, name the y-coordinate. Similarly, we would identify this point as the relative maximum, and we would say the function has a relative maximum at 0, the x-coordinate, and that value is 4, the y-coordinate. Now we'll take a look at some Mymathlab examples of these topics. The first thing I am asked to determine is where the function is increasing. Remember, a function is increasing when the values are going up as you read from left to right. And as I look at this graph, there are no such intervals. So the first answer is going to be choice B. There is no interval on which the function is increasing. Part B says look for open intervals on which the function is decreasing. I do have a section that's decreasing as I go from here to here. That is from a value of 2, and then it keeps going. So the x value on this end is going to be infinity. So when I write my open interval, I am only naming the x values. I'm going to say the function is decreasing. So we must use a round bracket, and then 2 to infinity would be the correct answer. For part C, we're asked on which intervals the function is constant. Constant functions will look like horizontal lines. So in this particular case, we're talking about this section of the graph. Now, if I'm going to name this as an open interval from lowest x value to highest x value, the lowest x value is somewhere out here at negative infinity, and my highest x value would again occur at 2. The answer for part C would be the open interval from negative infinity to positive 2. In the next question, we're given a graph of a function, and we're asked to figure out the values at which it has a relative maximum, and then calculate the relative maximum value. When you take a look at this graph, we have been given the function name, and down below here, I'm given the window settings. This was probably created by a graphing calculator. And when you look at this notation, the first set of parentheses has to do with the x-axis and how it's displayed on screen. It's telling us that the lowest x value on the screen is -5, the highest x value is 5, and the scale on the axis is 1. For the second part, that's always going to be the y-axis setup. It's telling us it's starting down here at -120, going up to +120, and it's counting off by intervals of 20. So starting at 0, this would be 20, 40, 60, 80, 100, 120. I am looking for the relative maximum. Well, there is one here where this point is higher than the points on each side of it. So that makes this one a relative maximum. If I read down to the axis, I can see that this is at the x value of -3, and that would be the answer that would go on the first blank. The location where the maximum occurs is always just the x value. To fill in the second blank, it says the relative maximum is, that's when you name the y-coordinate. And according to the directions, I am not just supposed to read over to the y-axis and try to estimate that. I'm supposed to use the equation to calculate it exactly. So in other words, I need to calculate what f of -3 is. So I'm going to substitute -3 in place of all of the x's. And I'm going to go term by term here. -3 cubed is -3 times -3, which is +9, times another -3, so it would be -27. Then I multiply by 2, so I get negative 54 here. Negative 3 squared becomes positive 9 times the 3 in front gives me a positive 27. This is a minus 36 times a minus 3, so that's going to be positive 108, and then plus 7. And now if you combine all those terms, this equals 88. And I can confirm that with my graph by reading across and saying 20, 40, 60, 80. It does look like it's just a little bit above 80. All right, now we repeat the same thing for the relative minima. So now we're going to look for the lowest point, and it seems like there's one right here. I'm going to again read back to the x-axis to get the first answer. Where is it located? Well, we can see that's at x equals positive 2. So that's the first answer. The actual minimum value would be found again by reading to the y-axis, but that's going to be slightly inaccurate. So therefore we can use the formula instead, the same way we did on the last one. And that's my answer for the second part, which again I can confirm by reading the approximate y-axis value from the graph. The rest of this graphing review will be in another video.